For thousands of years, humanity has looked up at the night sky and wondered what lies beyond. Long before telescopes existed, ancient civilizations studied the stars to navigate oceans, predict seasons, and understand their place in the universe. The stars inspired myths, religions, scientific discoveries, and dreams of exploration. Today, we stand at a remarkable point in the history. For the first time, humanity possesses the technology not only to observe distant worlds, but also to visit them. Space exploration represents one of the greatest adventures ever undertaken by our species. It is a journey driven by curiosity, courage, and the desire to expand the boundaries of human knowledge. When the first rockets were launched in the 20th century, few imagined that humans would walk on the moon within a few decades. Yet that achievement proved that seemingly impossible goals can become a reality through innovation, determination, and collaboration. The future of space exploration may be even more extraordinary. Scientists are planning permanent lunar bases missions to Mars, asteroid mining operations, and advanced telescopes capable of detecting signs of life on the distant planets. Private companies are reducing launch costs and making space more accessible than ever before. This story is not only about the technology, it is about humanity itself. Every generation inherits the dreams of those who came before. The explorers of the future will build open upon centuries of discovery and imagination. As we begin this journey through the future of space exploration, we will explore the possibilities, challenges, controversies, and hopes that may shape humanity's destiny among the stars. The universe is vast, mysterious, and filled with opportunities waiting to be discovered. The next great chapter of human history may not be written on the Earth alone. It may be written across the solar system and beyond. Many people think space exploration is only about astronauts and the rockets. In reality, it has transformed daily life on the Earth in ways most people rarely notice. The space age officially began in 1957 when the Soviet Union launched Sputnik, the world's first artificial satellite. The small metal sphere sparked a technological revolution that continues today. Governments invested heavily in the science, engineering, and innovation, leading to advances that spread throughout the society. One of the most important outcomes has been satellite technology. Today, satellites enable global communication, internet services, navigation systems, weather forecasting, disaster monitoring, and environmental research. Every time someone uses GPS on a smartphone, they benefit from technologies developed through space programs. Medical innovations have also emerged from the space research. Scientists studying human health in microgravity have contributed to advances in the medical imaging, remote healthcare systems, and new treatment methods. Materials originally developed for spacecraft have found applications in construction, transportation, and consumer products. Space exploration has also inspired generations of students to pursue careers in the science, technology, engineering, and mathematics. Many innovations that drive modern economies can trace their origins to investments in space research. Beyond technology, space exploration has changed humanity's perspective. Images of Earth taken from space reveals our planet as small, fragile world floating in vast universe. These photographs have strengthened environmental awareness and reminded people of our shared responsibility to protect our home. As we look towards future missions, the benefits of space explorations are likely to continue growing. New discoveries may lead to breakthroughs in energy, medicine, transportation, and communications. The history of space exploration demonstrates that investments in discovery often produces unexpected rewards. While the primary goal may be exploration, the benefits frequently improve life for billions of people on the earth. The future promises even greater opportunities as humanity expands its presence beyond our planet. Throughout history, civilizations that embraced exploration often advanced more rapidly than those that remained isolated. Exploration expands knowledge, creates opportunities, and drives innovation. Space exploration represents the next step in that timeless human journey. One important reason for continuing space exploration is scientific discovery. The universe contains countless mysteries. Scientists seek answers to fundamental questions about the origins of galaxies, stars, planets, and the life itself. Understanding these processes helps humanity better understand its own existence. Another reason is long term survival. Earth faces various natural and human made risks, including asteroid impacts, supervolcanic eruptions, climate challenges, and other potential threats. Establishing human settlements beyond Earth could help ensure the survival of civilization if catastrophic events occur on our home planet. Space exploration also stimulates economic growth. New industries are emerging around satellite services, space tourism, asteroid mining, and advanced manufacturing. These industries could create jobs, generate wealth, and drive technological innovation for decades to come. Curiosity remains one of humanity's most powerful motivations. Throughout history, explorers crossed oceans, climbed mountains, and ventured into unknown territories because they wanted to discover what lay beyond the horizon. Space represents the ultimate frontier. Critics sometimes argue that resources should be focused entirely on the problems of Earth. While these concerns deserve consideration, history shows that scientific exploration often produces solutions that benefit the society. Many technologies developed for space missions have improved healthcare, communications, transportations, and environmental monitoring. The future may include lunar cities, Martian settlements, and advanced spacecraft capable of traveling farther than ever before. These achievements could inspire generations and unite people around common goals. Exploration is not merely about reaching new destinations, it is about expanding human potential. By exploring space, humanity demonstrates its willingness to learn, adapt, and grow. The decision to continue exploring the cosmos reflects to optimism about the future and confidence in humanity's ability to overcome challenges through knowledge and cooperation. The original space race was largely a competition between two superpowers. Today, a new space race is unfolding, but it looks very different. Governments remain important players. Space agencies around the world continues to conduct scientific research, develop advanced technologies and plan ambitious exploration missions. At the same time, private companies have entered the field, bringing new ideas, competition, and investment. This combination of public and private participation is accelerating innovation. Reusable rockets, commercial satellite networks, and private lunar missions are transforming the economics of space exploration. The modern space race is not only about the prestige, it involves scientific leadership, economic opportunities, technological advancement, and access to the valuable resources. Nations recognize that space may play a major role in the future economic and strategic development. International cooperation is also increasing. Complex missions often require expertise, funding, and infrastructure from multiple countries. Collaborative projects demonstrates how space exploration can unite people across political and cultural boundaries. Private companies are introducing a new level of speed and flexibility. Entrepreneurs are pursuing ambitious goals that once seemed impossible, including large-scale Mars colonization and commercial space tourism. However, competition also raises important questions. How should the space resources be managed? Who should govern future settlements on the Moon or Mars? How can nations prevent conflicts in the space? These issues will become increasingly important as human activity expands beyond Earth. Despite the challenges, the new space race represents one of the most exciting periods in the history of exploration. Multiple organizations are pursuing groundbreaking technologies that could transform humanity's relationship with the space. The next few decades may witness achievements that rival or even surpass the Apollo moon landings. Humanity is entering a new era in which access to space becomes more frequent, more affordable, and more ambitious than ever before. For decades, one of the greatest obstacles to space exploration was the cost. Traditional rockets were typically used only once. After launch, most components were discarded, making space missions extremely expensive. Imagine if every airplane were thrown away after a single flight. Air travel would be prohibitively expensive. The same principle applied to the rockets. The development of reusable rockets technology has changed everything. Engineers realized that recovering and reusing major rocket components could dramatically reduce launch costs. This breakthrough is helping make space explorations more sustainable and economically viable. Reusable rockets can return to Earth, land safely, undergo inspections, and fly again. This approach reduces manufacturing costs and increases launch frequency. As a result, more organizations can participate in the space activities. Lower launch costs benefit many industries. Satellite operators can deploy new systems more affordably. Scientific organizations can conduct more research missions. Governments can pursue ambitious exploration programs with improved efficiency. The long-term implications are even more significant. Affordable transportation is essential for establishing permanent human settlements beyond Earth. Lunar bases, Martian colonies, Lunar bases, Martian colonies, and orbital habitats all require reliable and cost-effective transportation systems. Reusable rockets are also encouraging innovation throughout the aerospace industries. Companies are developing new propulsion systems, advanced materials, and improved manufacturing techniques. Critics note that challenges remain. Rocket maintenance, safety requirements, and operational complexity still contribute to the costs. Nevertheless, the progress achieved over the past decades demonstrates that reusable launch systems can fundamentally transform access to the space. Many experts believe this revolution is only beginning. Future generations of spacecraft may become even more efficient, enabling frequent travel between Earth, the Moon, and the Mars. The reusable rocket revolution is not simply a technological achievement. It represents a critical step towards making humanity a truly space-faring civilization. More than half a century has passed since humans first walked on the moon. For many years, lunar exploration slowed, and some people wondered whether humanity would ever return. Today, however, the moon is once again becoming the focus of global attention. The next generation of lunar missions is very different from the Apollo era. The goal is no longer to visit the moon for a few days and return home. Instead, the scientists and engineers are planning permanent human presence on the lunar surface. The moon is being viewed as a stepping stone towards deeper exploration of the solar system. One of the most exciting discoveries in the recent decades is the presence of water ice in permanently shadowed craters near the moon's poles. This resource could become essential for future exploration. Water can be used for drinking, growing food, producing oxygen, and even creating rocket fuel through chemical processes. In other words, lunar ice could help transform the moon from a destination into a sustainable base of operations. Future lunar bases may serve many purposes. Scientists could conduct experiments impossible on the Earth. Astronomers could build powerful observatories on the moon's far side, free from Earth's radio interference. Engineers could test technologies required for Mars missions and long duration space travel. The moon also offers economic possibilities. Some experts believe future industries may extract resources from the lunar surface. While such plans remain speculative, they demonstrate how the moon could play an important role in the humanity's future economy. Challenges remain significant. Lunar temperatures vary dramatically, radiation exposure is high, and transportation remains expensive. Yet each challenge inspires innovation. The return to the moon symbolizes more than scientific progress. It represents humanity's willingness to continue exploring despite obstacles. Future generations may look back on this era as the moment when humanity began building its first permanent foothold beyond the Earth. The moon is no longer merely a distant object in the night sky. It is becoming the first chapter of humanity's expansion into the cosmos. Imagine standing inside a city on the moon. Outside the habitat, the landscape appears silent and untouched. Above, Earth shines brilliantly against the blackness of space. What once seemed like science fiction may become reality within this century. Building cities on the moon will require extraordinary engineering and creativity. Unlike the Earth, the moon has no breathable atmosphere, limited natural protection from radiation, and extreme temperature fluctuations. Future settlers must overcome these challenges to create safe and sustainable communities. One proposed solution involves constructing habitats underground or covering structures with lunar soil known as regolith. This natural shielding could help protect residents from harmful radiation and micrometeoroids. Scientists are also exploring the possibility of using lunar materials themselves as construction resources, reducing the need to transport everything from Earth. Energy production will be critical. Solar power is expected to play a major role, particularly near the lunar poles where sunlight can be available for extended periods. Advanced energy storage systems may provide electricity during periods of darkness. Food production presents another challenge. Future lunar cities may use controlled environment agriculture, hydroponics, and advanced recycling systems. Water recovered from lunar ice could support both human consumption and agricultural activities. Transportation systems may connect different lunar settlements, autonomous vehicles, robotic mining equipment, and communication networks could create an interconnected lunar infrastructure. Yet the greatest challenge may not be technological, it may be human. Living in isolated environments far from Earth will test psychological resilience, teamwork, and social organization. Future lunar communities may develop systems that support mental health, education, culture, and governance. Despite these challenges, lunar cities could become symbols of human ingenuity. They would demonstrate our ability to adapt to the environments vastly different from our home planet. The creation of cities on the moon would mark one of the most important milestones in the human history. For the first time, civilization would exist permanently beyond Earth, opening the door to an entirely new era of exploration and opportunity. If the moon is humanity's first destination beyond Earth, Mars is often considered the ultimate prize. For generations, the red planet has captured human imagination. Today, advances in technology are bringing the possibility of human missions closer than ever before. Mars offers several advantages compared to the other planets. It has seasons, polar ice caps, and evidences that liquid water once existed on its surface. Although its environment remains sparse, it is considered one of the most promising locations for future human settlement. The journey to Mars, however, is incredibly challenging. Depending on planetary positions, travel times may take several months. During this period, astronauts would face isolation, confined living conditions, and exposure to the cosmic radiation. Unlike missions to the moon, emergency returns from Mars would be extremely difficult. Astronauts must be prepared to solve problems independently, often with significant communication delays. A message sent between Earth and the Mars can take many minutes to arrive, making real-time assistance impossible. Scientists are developing advanced life support systems capable of recycling air, water, and waste. These technologies will be essential for sustaining human crews during long voyages. Psychological preparation is equally important. Future Mars explorers may spend years away from Earth. Researchers are studying how individuals and teams respond to isolation in remote environments to better prepare astronauts for these conditions. For many people, Mars represents more than a specific or scientific destination. It symbolizes humanity's willingness to pursue ambitious goals and push beyond perceived limits. The first human footsteps on the Mars may become one of the defining moments of the 21st century, inspiring generations and reshaping humanity's understanding of what is possible. Landing on the Mars is only the beginning. The real challenge is learning how to live there. Mars presents a hostile environment. The atmosphere is thin, temperatures are extremely cold, and radiation levels are much higher than on the Earth. Yet scientists believe these challenges can be overcome through innovation and careful planning. Future Martian settlements may begin as small scientific outposts. Over time, these bases could grow into self-sustaining communities. Habitats may be built using local materials, reducing dependence on supplies transported from the earth. Water will be one of the most valuable resources. Fortunately, evidences suggests significant quantities of frozen water exist beneath the Martian surface. This resource could support drinking, agriculture, and industrial process. Food production will require advanced agricultural systems, greenhouses using artificial lighting, and controlled environments may enable settlers to grow fruits, vegetables, and other crops. Efficient recycling systems will be essential for conserving resources. Social structure will also evolve. Future Martian communities may develop unique cultures influenced by their environment and shared experiences. Education, healthcare, governance, and recreation will all play important roles in maintaining the quality of life. Some experts predict that Mars could eventually host thousands or even millions of people, while such visions remain speculative. They highlight the transformative possibilities of human expansion into the space. Living on Mars would require resilience, adaptability, and cooperation, yet it would also offer extraordinary opportunities for discovery and innovation. While many discussions focus on the Moon and the Mars, some experts believe humanity's future may lie in giant habitats floating in the space itself. Orbital cities could provide living space for millions of people without requiring settlement on planetary surfaces. These structures would orbit Earth, the Moon, or other locations throughout the solar system. One of the most fascinating concepts involves rotating habitats. By spinning, these structures could generate artificial gravity through centrifugal forces. Residents might experience conditions similar to those on the Earth, making long-term habitation more comfortable and sustainable. Orbital cities could contain homes, schools, hospitals, parks, research facilities, and industrial centers. Advanced recycling systems would conserve resources, while solar power could provide abundant energy. Such habitats offer several advantages. Unlike planetary settlements, their environments can be carefully controlled. Engineers could design optimal living conditions, adjusting temperature, lighting, and gravity as needed. Manufacturing in the space may also become economically valuable. Certain products can be produced more efficiently in microgravity, potentially creating entirely new industries. Of course, significant challenges remain. Constructing massive orbital habitats would require enormous resources and technological capabilities. Transportation systems must become far more affordable and reliable. Safety concerns, including radiation protection and collision risk, must also be getting addressed. Despite these obstacles, orbital cities remain one of the most intriguing visions of humanity's future. They represent a future in which human civilization expands throughout the solar system rather than remaining concentrated on a single planet. The concept encourages us to think beyond traditional limitation. Instead of adapting to the planets, humanity might create entirely new environments tailored to human needs. If realized, orbital cities could become some of the most remarkable engineering achievements ever constructed, floating symbols of humanity's creativity, ambition, and determination to explore the universe. For decades, space travel was reserved for a small group of highly trained astronauts. The enormous costs, technological complexity, and risks placed space far beyond the reach of ordinary people. Today, however, a remarkable transformation is underway. Space tourism is beginning to emerge as one of the most exciting industries of the 21st century. The first generation of space tourists have already demonstrated that commercial space travel is possible. Wealthy individuals have experienced brief journeys beyond Earth's atmosphere, witnessing the curvature of our planet and the darkness of space with their own eyes. These early flights represent only the beginning of a much larger transformation. Future space tourism may include suborbital flights, orbital vacations, luxury space hotels, and even lunar sightseeing missions. Engineers are designing spacecraft capable of carrying large number of passengers while maintaining high safety standards. The technology advances and launch costs decline, space travel could become increasingly accessible. One of the most powerful aspects of space tourism is the perspective it offers. Astronauts often describe a phenomenon known as the overview effect, a profound shift in awareness that occurs when viewing Earth from the space. Borders disappear, political divisions fade, and our planet appears as a fragile home shared by all humanity. Space tourism may also stimulate economic growth. New industries involving hospitality, transportation, entertainment, and training could emerge around commercial space travel. This expansion could create jobs and encourage further technological innovation. Critics argue that space tourism may initially remain accessible only to the wealthy. While this concern is valid, many technologies follow a similar pattern. Air travel, computers, and mobile phones were once expensive luxuries before becoming widely available. The future may bring experiences that previous generations could only imagine. Families might celebrate special occasions in orbit. Students could participate in educational space programs. Space tourism is not merely about recreation, it represents a significant step towards normalizing human activity beyond the Earth. As more people experience space firsthand, public interest in exploration may grow, inspiring future generations to pursue scientific and technological careers. Deep within our solar system travel millions of asteroids, ancient remnants from the formation of planets. For centuries, they were viewed primarily as scientific curiosities. Today, some experts believe these objects could become one of humanity's most valuable resources. Many asteroids contain significant quantities of metals and minerals. Some are believed to contain platinum, nickel, iron, cobalt, and rare elements that are essential for advanced technologies. In some cases, a single asteroid may contain resources worth billions or even trillions of dollars. The concept of asteroid mining may sound futuristic, but serious research is already underway. Scientists are studying how robotic systems could identify, reach, and extract valuable materials from these objects. Advances in automation and artificial intelligence may take such operations increasingly feasible. One of the greatest advantages of asteroid mining is that it could reduce pressure on the Earth's natural resources. As global demand for technology grows, access to additional sources of rare materials could support sustainable economic development. Asteroids may also provide resources needed for future space exploration. Water extracted from certain asteroids could be converted into oxygen for breathing and hydrogen fuel for the spacecraft. Rather than transporting everything from the Earth, future explorers could obtain supplies directly in the space. Ethical and legal issues are equally significant. Who owns asteroid resources? Should private companies have exclusive rights to materials found in the space? How should benefits be distributed among the nations? These questions have no simple answers, but they will become increasingly important as the space activities get expanded. Asteroid mining represents a fascinating example of how exploration can create entirely new opportunities. What once seemed like distant rocks drifting through space may eventually become key resources supporting humanity's future among the stars. Perhaps no question has captured human imagination more than this. Are we alone in the universe? For thousands of years, people have wondered whether life exists beyond the Earth. Today, advances in astronomy, biology, and planetary science are bringing humanity closer than ever to answering that profound questions. Scientists have discovered that planets are incredibly common throughout the universe. Thousands of exoplanets, worlds orbiting distant stars, have already been identified. Many appeared to exist within regions where liquid water could potentially exist, sorry, making them candidates for supporting the life. Finding even simple microbial life would be one of the greatest discoveries in the human history. It would demonstrate that life is not unique to Earth and may emerge wherever suitable conditions exist. The discovery of intelligent extraterrestrial civilizations would have even greater implications. Such a finding could transform science, philosophy, religion, and humanity's understanding of its place in the cosmos. Despite decades of investigation, no definitive evidences of extraterrestrial life has yet been confirmed. However, the search continues because the potential rewards are extraordinary. Even if we do not find alien life soon, the process of searching teaches us valuable lessons about biology, planetary systems, and the conditions necessary for the life to exist. The search for alien life is ultimately a search for understanding. By exploring other worlds, we learn more about our own world and about the remarkable processes that allowed life to emerge on the Earth. Just a few decades ago, scientists could only speculate about planets orbiting other stars. Today, thousands of exoplanets have been discovered, revealing a universe filled with astonishing diversity and possibility. Some exoplanets are giant worlds larger than Jupiter. Others orbit multiple stars. Some are scorching hot, while others may possess conditions similar to the Earth. Each discovery expands our understanding of planetary systems and challenges previous assumptions about how worlds form and evolve. Among the most exciting discoveries are Earth-like planets located within their star's habitable zone. This region is often described as Goldilocks zone because conditions may be neither too hot nor too cold for liquid water to exist. Future telescopes will be capable of analyzing exoplanet atmospheres in unprecedented details. Scientists hope to identify biosignatures, chemical indicators that may suggest the presence of living organisms. The discovery of a truly Earth-like world could have profound implications. Such planets may become future destinations for robotic exploration and perhaps one day human missions. Exoplanet research also changes our perspective on the Earth. By comparing our planet with the other, scientists gain deeper insights into climatic systems, planetary evolution, and habitability. Every newly discovered world reminds us that Earth is part of a much larger cosmic story. The universe may contain countless planets, each with its own history, environment, and potential for the life. Humanity may one day journey to distant stars, but the first step begins with discovering the worlds that surround them. Throughout history, breakthroughs in transportation have transformed civilization. Ships connected continents, railways accelerated commerce, and airplanes made global travel routine. The future of space exploration may depend on another revolutionary transportation concept, the space elevator. A space elevator is a theoretical structure extending from Earth's surface into the space. Instead of launching rockets, vehicles could climb along a massive cable reaching beyond geostationary orbit. This concept has fascinated scientists and engineers for decades because it could dramatically reduce the cost of accessing space. The idea sounds simple, but the engineering challenges are enormous. The cable would need to be constructed from materials stronger than anything currently produced at a large scale. Researchers continue investigating advanced materials such as carbon nanotubes and other ultra strong composites that might one day make the concept feasible. Even if the space elevators remain decades away, many other transportation innovations are under development. Scientists are exploring electromagnetic launch systems, reusable spacecraft, nuclear propulsion technologies, and advanced engines capable of significantly reducing the travel times. Transportation infrastructure has always played a central role in the economic development. The same principle will likely apply to the space. Efficient transportation systems could support commerce, research, tourism, and settlement throughout the solar system. The future of space exploration depends not only on where we want to go, but also on how we get there. Every improvement in the transportation expands opportunities and makes ambitious goals more achievable. The dream of traveling freely between worlds may seem distant, but so once did the dream of flight. History repeatedly demonstrates that human imagination often becomes reality through persistence, innovation, and vision. Artificial intelligence, often called as AI, is rapidly becoming one of the most important technologies shaping the future of space exploration. While rockets and spacecraft receives most of the attention, AI may ultimately become the invisible force that enables humanity to explore farther and more efficiently than ever before. Space missions generate enormous amounts of data. Telescopes observe distant galaxies, satellites monitor Earth, and robotic probes analyze planets, moons, and asteroids. Human scientists alone cannot process all this information quickly enough. AI systems help identify patterns, classify objects, and discover important insights hidden within a vast data sets. Robotic explorers powered by AI may become humanity's first representatives on distant worlds. They can navigate challenging terrain, identify scientifically valuable targets, conduct experiments, and adapt to changing conditions. These capabilities dramatically increase mission efficiency, and scientific productivity. The technology is not without challenges. Reliability and safety remains critical concerns. Space environments are harsh, and AI systems must operate correctly under extreme conditions. Ethical questions also arise regarding decision making, authority, and human oversight. In many ways, AI will serve as humanity's partner in exploring the cosmos. Together, humans and intelligent machines may unlock discoveries that neither could achieve alone. The future of space exploration may not belong solely to the astronauts or robots, but to the collaboration between the both. As exploration expands deeper into the universe, AI may become one of the humanity's most valuable allies. Every major era of exploration has been defined by advances in transportation technology. Sailing ships opened new continents, steam engines transformed trade, and aircraft connected the world. The future of space exploration will similarly depend on revolutionary spacecraft technologies. Traditional chemical rockets have served humanity well, but they have limitations. Interplanetary travel remains slow, expensive, and energy intensive. Scientists and engineers are therefore developing advanced propulsion systems capable of dramatically improving the performance. One promising technology is nuclear propulsion. Nuclear powered spacecraft could provide greater efficiency than conventional rockets, reducing travel times to destinations such as Mars. Shorter journeys would improve safety by reducing astronauts' exposure to radiation and isolation. Looking further into the future, fusion propulsion represents one of the most exciting possibilities. Fusion is the same process that powers the stars, including our sun. If engineers can harness fusion effectively, spacecraft may achieve speeds far beyond current capabilities, opening new opportunities for deep space exploration. Spacecraft design is evolving as well. Future vehicles may use advanced materials, autonomous systems, modular construction techniques, and in-space manufacturing capabilities. These innovations could increase durability, reduces the cost, and improve mission flexibility. The future of exploration depends on overcoming the immense distances that separate the worlds. Advanced spacecraft technologies may eventually transform our solar system from a collection of distant destinations into an interconnected frontier of discovery. For thousands of years, humanity explored new lands on the Earth. Today we explore our solar system, but what lies beyond? Can humans one day travel to the other stars? Interstellar travel remains one of the greatest challenges in the science and engineering. The distances involved are almost unimaginable. Even the nearest star system beyond our sun is more than 4 light years away. Using today's technology, such a journey would take tens of thousands of years. Despite these obstacles, scientists continue exploring possible solutions. One concept involves generation ships, massive spacecraft designed to support multiple generations of travelers during centuries long journeys. Another possibility is cryogenic preservation. Future travelers might enter suspended states during long voyages, reducing resources requirements and allowing them to survive journeys lasting decades or the centuries. Some theoretical concepts go even further. Ideas such as warp drives and wormholes appear in the science fiction but are also subjects of serious theoretical investigation. Although current scientific understanding does not confirm their feasibility, they encourage exploration of fundamental physics. These questions inspire both scientists and dreamers. Even if practical interstellar travel remains centuries away, research conducted today contributes to the future possibilities. The pursuit of interstellar travel reflects humanity's refusal to accept the limits. It demonstrates a willingness to imagine futures far beyond our current capabilities. One day, descendants of today's explorers may stand beneath aligned skies, looking back towards the Earth as a distant star. If that moment ever arrives, it will represent one of the greatest achievements in the human history. The journey to the stars may be long, but every great adventure begins with a single step. Sorry. Exploration is often associated with the discovery and adventure, but it also serves another critical purposes, protecting the Earth. Throughout Earth's history, asteroid impacts have shaped the evolution of life. Scientists believe a massive asteroid impact contributed to the extinction of the dinosaurs approximately 66 million years ago. Such events remind us that planetary defense is not merely science fiction, it is a real responsibility. One of the most important developments in planetary defense has been the testing of asteroid deflection techniques. Rather than waiting for a dangerous object to strike the Earth, scientists are investigating ways to alter its trajectory. Robotic spacecraft may play a central role in these efforts. Future missions could study threatening asteroids, evaluating their composition, and deploying technologies designed to redirect them safely away from the Earth. The planetary defense requires international cooperation. Asteroids do not recognize national borders, and a significant impact could affect the entire planet. Scientists, engineers, governments, and organizations worldwide must work together to address potential threats. Space exploration contributes directly to this effort by improving observation systems, advancing spacecraft technologies, and increasing scientific understanding of near Earth objects. Protecting Earth from impacts demonstrates one of the most practical benefits of a space exploration. It shows how scientific knowledge can help safeguard humanity's future. The same technologies that allow us to explore distant worlds may also help ensure that our own world remains safe for generations to come. While space exploration inspires excitement and optimism, it is not without controversy. Throughout history, ambitious projects have generated debate, and space programs are no exception. One of the most common criticisms concerns cost. Some people argue that billions of dollars spent on the space exploration should instead be directed towards addressing poverty, healthcare, education, climate challenges, and other urgent issues on the Earth. These concerns deserve serious consideration because resources are limited and societal priorities matter. Another controversy involves the commercialization of space. Private companies are playing an increasingly important role in exploration, transportation, and satellite deployment. Supporters argue that competition encourages innovation and reduces the costs. Critics worry about monopolies, unequal access, and excessive corporate influences over humanity's future in the space. Questions of ownership and governance create additional debate. Who should control the lunar resources? Should private organizations profit from asteroid mining? How should future settlements on the moon or Mars be governed? Military activities in the space present another area of concern. Satellites are critical to national security, communication, and navigation systems. As more nations develop space capabilities, policymakers must balance security interests with the goal of maintaining peaceful exploration. These controversies are not the sign of failure, rather, they reflect the complexity of expanding human activity into a new frontier. Thoughtful debate helps societies make informed decisions and develop responsible policies. The future of a space exploration will require balancing ambition with responsibility. By addressing concerns openly and honestly, humanity can pursue exploration while respecting ethical, environmental, and social considerations. Every great journey involves difficult questions. The challenge is ensuring that our answers reflect both wisdom and the vision. Every major human achievement has faced criticism. The construction of railroads, the development of aviation, the exploration of oceans, and even the creation of the internet were all questioned by many people during their early stages. Space exploration is no different. Critics often ask whether humanity should spend resources exploring distant worlds when significant challenges still exist on the Earth. This question deserves a thoughtful answer. The reality is that space exploration and solving Earth's problems are not mutually exclusive goals. Throughout history, investments in exploration have frequently produced technologies that improve everyday life. Satellites help monitor climatic change, predict weather patterns, support agriculture, provide internet access, and assist during natural disasters. Space programs also drive innovation. Engineers developing technologies for extreme space environments often create solutions that find applications in medicine, transportation, communications, and manufacturing. Many products used today have roots in space-related research and development. Economic benefits are another important consideration. Space exploration supports high-skilled jobs, encourages education in science and engineering, and stimulates entire industries. Future sectors such as space tourism, asteroid mining, and orbital manufacturing may create new opportunities for the economic growth. Another criticism involves risk. Exploration has always involved uncertainty, yet progress frequently depends on individuals' willingness to pursue ambitious goals despite challenges. The explorers who crossed oceans centuries ago faced dangers that seemed overwhelming, but their efforts transformed the civilization. The goal is not to ignore the problems on Earth, rather, it is to recognize that exploration can continue to solve them by investigating or investing in the knowledge, technology, and the discovery. Humanity strengthens its ability to address challenges both on the Earth and beyond. As humanity prepares to expand beyond the Earth, technological challenges are only part of the equation. Ethical questions may prove equally important. Colonizing space is not simply about building habitats and launching the spacecraft. It is about deciding what kind of civilization humanity wants to create. One major question concerns ownership. If valuable resources are discovered on the moon, Mars, or asteroids, who should control them? Should they belong to the First Nation or company that riches them? Should they be considered the shared heritage of humanity? International agreements provide some guidance, but many issues remain unresolved. Environmental responsibility must also be considered. Scientists are committed to protecting other worlds from contamination. Introducing Earth based organisms could interfere with the search for indigenous life and alter environments that have remained unchanged for billions of years. Human rights will require careful consideration as well. The future settlers may live in isolated environments where resources are limited and survival depends on a strict cooperation. Balancing individual freedoms with collective safety will be essential. Addressing ethical questions early allows humanity to build a foundation for responsible exploration. Technological success alone is not enough. Lasting progress requires wisdom, fairness, and respect for both people and the environment. The future of space colonization will not be defined solely by engineering achievements. It will also be shaped by the values humanity chooses to carry into the cosmos. Space exploration is often portrayed as a competition, but some of its greatest achievements have emerged through cooperation. As missions become increasingly ambitious and complex, international partnerships are becoming more important than ever. No single nation possesses unlimited resources. Large scale exploration programs require scientific expertise, engineering talent, financial investment, and technological infrastructure. By working together, countries can accomplish goals that might be difficult to achieve alone. One of the most successful examples of international cooperation is the International Space Station. Built and operated through collaboration among multiple nations, it has hosted astronauts from around the world and supported thousands of scientific experiments. The station demonstrates how shared goals can overcome political differences. Cooperation also promotes peace. When scientists and engineers from different nations work together, they build relationships based on mutual respect and common objectives. These partnerships can strengthen diplomatic ties and encourage understanding across cultures. The challenges facing humanity are increasingly global in the nature. Climate monitoring, asteroid defense, and the search for extraterrestrial life are not the concerns of any single country. They are challenges and opportunities that affect all humanity. Of course, cooperation is not always easy. Political differences, strategic interests, and economic competition can create the tensions. However, history shows that shared goals often encourage collaboration even during the periods of disagreement. As humanity ventures farther into the space, international partnerships may become one of our greatest assets. The exploration of the cosmos offers an opportunity not only to discover new worlds but also to demonstrate what humanity can achieve when united by a common purpose. Discussions about the future often focus on the risks and uncertainties. While challenges certainly exist, it is equally important to recognize the extraordinary opportunities that space exploration may create for future generations. A thriving space economy could support millions of jobs and industries that do not yet exist. New forms of energy production, manufacturing, transportation, tourism, and scientific research may sorry, emerge as humanity expands its presence beyond the Earth. Space exploration may also contribute to sustainability. Resources obtained from asteroids and other celestial bodies could reduce pressure on Earth's environment. Space-based solar power systems, advanced recycling technologies, and innovations developed for off-world habitats may help address challenges on our home planet. Future generations may grow up viewing the moon, Mars, and orbital habitats as familiar destinations. What seems extraordinary today may become routine tomorrow. Entire new cultures, professions, and communities could emerge beyond the Earth. The future of humanity in space is not guaranteed. It will require efforts, innovation, and wise decision making, yet the potential rewards are extraordinary. The story of a space exploration is ultimately a story of possibility. It reflects humanity's ability to imagine a better future and work towards achieving it. The opportunities ahead may exceed anything previous generations could have imagined. Every achievement in the space exploration rests upon the efforts of countless individuals. When people watch a rocket launch or celebrate a scientific discovery, they often see only the final result. Behind every success stands a vast network of explorers, scientists, engineers, technicians, educators, and dreamers whose contributions made it possible. Many pioneers worked during the times when success seemed uncertain. Early rocket scientists faced skepticism and limited resources. Astronauts accepted extraordinary risks in pursuit of knowledge. Researchers devoted decades to solving complex problems that sometimes produced results only after years of effort. Gratitude should also extend to teachers and educators who inspire curiosity. The next generation of explorers begins with students who learn about science, mathematics, engineering, and the wonders of the universe. Education serves as the foundation for future discoveries. Space exploration reminds us that progress is a shared achievement. The technologies, knowledge, and opportunities available today exist because previous generations invested in research, education, and innovation. Reflecting on these contributions encourages humility. The accomplishments of the present depend upon the efforts of countless individuals across many decades. Likewise, future achievements will depend upon the work being done today. Gratitude is more than appreciation for past accomplishments. It is recognition of humanity's collective capacity to learn, create, and explore. It acknowledges that great achievements become possible when people work together towards common goals. As we look towards the future, it is worth remembering those who helped make that future possible. Their curiosity, courage, and perseverance continues to guide humanity's journey into the cosmos. As we reach the conclusion of this journey, we return to the question that has inspired explorers throughout history. What comes next? Humanity stands at the threshold of a new era. For the first time, the technologies needed to establish a lasting presence beyond the Earth are beginning to emerge. Lunar bases, missions to Mars, advanced spacecraft, artificial intelligence, asteroid mining, and even interstellar exploration are moving from imagination towards the reality. The future will not arrive overnight. The progress will occur through thousands of individual breakthroughs, countless experiments, and the efforts of generations working together. There will be successes and the setbacks, moments of triumph and periods of uncertainty. Such challenges have accompanied every great chapter of human history. Perhaps one day, children born on the Mars will study Earth's history the way people today study ancient civilizations. Perhaps future observatories will discover life on the distant worlds. Perhaps human explorers will journey between stars, carrying with them the knowledge, culture, and aspirations of Earth. No one can predict exactly what the future will hold. Every generation inherits a frontier. For previous generations, it was oceans, continents, and the skies. For ours, it is space. The stars that inspired ancient dreamers still shine above us today. They are no longer merely distant lights. They are destinations, opportunities, and symbols of humanity's endless desire to learn and explore. The future of space exploration is ultimately the future of humanity itself. And that future has only just begun. Thank you.